Hey guys, Miss Quick here to help you set up your graph for station number 4. Now at this station, what we're saying is that we have done an experiment where we've rolled a bowling ball, we've timed it for 5, 10, and 15 seconds, and one of our partners has measured how far the bowling ball has rolled each time that we have timed it. So, if we roll the bowling ball, we let it roll for 5 seconds, and then we stop it, then our partner has measured, it's gone 15 meters. Same thing, if we bring it back and try it again, we roll it for 10 seconds, stop the bowling ball, and measure how far it's gone 25 meters this time. And if we bring it back, we roll it again, time it, and we let it go for 15 seconds, then how far did it go? On here it says it went 30 meters. Now to set up your graph, first we have to know which one of these is our independent and dependent variables. Now a good rule of thumb is the independent variable is always on the left. Okay, just like Beyonce says, independent woman, independent variable goes in the box on the left. To the left, to the left. Anyways, that means that anything on the right side is going to be your dependent variable. Okay, so our independent is always on the left. Our dependent is anything on the right. Okay, another way to remember it, if you notice down here, I put a little note to myself that says before, and over here I put a little note that says after. The independent numbers are what you know before the experiment ever starts. So, before we ever even rolled our first bowling ball, we had already planned out that we were going to time it for 5, 10, and 15 seconds. So, the independent is what you know before the experiment starts. And the distance, we would have no idea what those numbers would be until after the experiment, after we measured them. So those are our after numbers. So whatever memory tool you use to remember it, independent is going to be the time in this case, and the dependent is going to be the distance in meters. Make sure in parentheses that you have your units. We measured time in seconds and distance in meters. The next thing your graph needs is a number line on the x and y axis. At the 6th grade level, you don't have to know how to set up the number line by yourself. But coming up in 7th and 8th grade, you will become more independent because you will have to do this on your own. So what I've done for you here is I put a dash and I put 0 at my origin, and that's where 0 always goes on your graph. Then to set this number line up, first I set up the spacing of my numbers by putting these little dash marks, which you should do also. Second, I added my numbers in. You should always put the dash marks first and the numbers second, because once you get up here into double digits, or if you had triple digits, it would be very hard to tell which line each number was associated with. So on our bottom line, I counted up, there are 32 lines. But I just need to get up to 15. So what I've done is I skipped a line, put a dash, skipped a line, put a dash, skipped a line, put a dash, all the way across. And then I numbered by ones, 1, 2, 3, 4, so on and so forth, all the way to 16 is where I stopped. On your y-axis, there are 20 lines here. I counted them up. There are 20 of them. I have to number all the way to 30. So what I did, starting at 0, I skipped a line, put a dash, skipped a line, put a dash, skipped a line, put a dash, just like we did here on the bottom. At this time I numbered by 5s, 5, 10, 15, 20, 25, 30, and got up to 50. So please set your number lines up like mine. Feel free to pause the video at any time and unpause whenever you're ready to move forward. All right. The next section, we have to plot our points. Now, from math and from talking to you guys yesterday, what I found out is you guys have, you know a little bit about graphs already. So to set up a coordinate point, it's x, comma, y. That's your point. So what I did is I took these numbers and I rewrote them as coordinate points. So my first point that I have to plot is 5, 15. My second is 10, 25. My third is 15, 30. These are the points that I need to plot. So, a fast way that I showed the other groups to do this is by using a ruler. It doesn't have to be a ruler. It can be anything with a straight edge. So, I don't have a ruler handy, but I can just use this straight edge. This is going to help me save my place, and it's going to help me to graph my points faster, right? We all want to look for the most efficient, fastest most effective way to do our assignment. So this, using a straight edge, will help you graph your points faster. So our first point is 5:15. So I'm going to use my finger to go over 5 first. I'm going to use my straight edge to line up my 15, and I'm going to put my first point. I'm going to darken it in, make it very thick and noticeable so I don't have to look for it later, okay? So using this straight edge is going to help you plot your points faster, because if you're just eyeballing it, there's a chance you can make a mistake. Or if you're just using your fingers, there's a chance that your fingers are not always going to line up perfectly, and you can make a mistake that way. So the straight edge is fast, effective, and you can get your work done. The next point we have to plot is 10:25, so I use my finger to go over to 10, my straight edge to mark my line at 25, and plot my point. And my last point is going to be 15:30, so I'm going to use my finger to go over to 15, my straight edge to line up at 30, and plot my last point. Okay? When I connect my dots, I must use a straight edge, like a ruler, to plot these points and connect my lines so that my graph looks neat, easy to read, and not sloppy. Okay? So don't just hand draw your lines. You are not a human ruler. Please use some type of straight edge or ruler to make sure your lines look neat and organized and tidy. Okay? And there's our graph. So once we finish our graph, there are a couple questions down here at the bottom. And you should be able to use this line, which shows our bowling ball's distance over time. And what we should see is that as the time got greater and greater, from 5 seconds to 10 seconds to 15 seconds, the bowling ball's distance, it rolled farther and farther and farther each time. So use that information to answer, what does this graph show about the bowling ball's motion? And what can be said about how SpongeBob, characters up here in our description, how SpongeBob needed to roll the ball each time. So really we're thinking about, remember, energy forces machines. So if the ball went farther and farther each time, and we timed it for different amounts of time, what kind of force do you think SpongeBob had to use each time he rolled the ball to make this a fair test? Okay? Good luck. I'll see you in class. Thanks for listening.